Good morning, everybody. We're going to talk about integers today. And I just want to get a quick video out there. This is a fairly brief SOL. There's not a whole lot of operational stuff involved here. It's really just the concept of integers. So here we go. Please feel free to pause if you need to. If you need to take notes, I recommend that. A lot of this is what you'll see on an actual examination, so make sure that you're aware of it and be ready to talk about it in class and bring any questions with you to class. Integers are the set of whole numbers and their opposites. So we're talking about positive numbers, we're talking about negative numbers, but through and through they are all whole numbers. Some examples of integers you see right here. Obviously write these things down, use these as examples to drive your learning. And some good non-examples, I think they're really important to write down. Fractions are not integers. Decimal values are not integers. Threw pi on there just because, but it does fit as well. Pi is a non-terminating, non-repeating value. 3.14159, yada yada yada. It's not going to be an integer. Anything that looks like a mixed number, again, not an integer. Even though 8 is an integer, 2/3 is not, and the combination of those values would make it not an integer. You might notice that in the examples section, we have some things that look a little bit weird because they don't look like whole numbers. So let's look at that kind of closely and then we'll move on. 7, obviously, a whole number. 0 is a whole number. It is not positive, it is not negative, but it is still an integer because it is a part of that set. -3, obviously, whole number. It's less than 0. Or we have 100%. That sounds kind of strange because a percent usually is something that is less than a whole of something. However, 100% is one whole. If I had 100% of a pizza, I'd have a whole pizza. So this is an example of an integer, as long as you were to convert it and understand the fact that it does turn into 1, which is an integer. That's an improper fraction. The fact that it's an improper fraction should give us a little bit of pause. However, if we were to simplify that, 8 over 2, or 8 divided by 2, if you were to think about it, to calculate it, is 4, and 4 is an integer. So it's okay to have fractional values like this to be presented as an integer, as long as you understand the fact that it needs to be simplified to the point where it looks like an integer. Some things that come up in conversation with integers, especially when we're talking about ordering and comparing them. If we have a string of values that we want to put in order from greatest to least or least to greatest, ascending order, descending order, we use these phrases interchangeably, is that a positive value is always bigger than a negative value. And the cue that I want to give you is to look at a number line. I don't know if you can see this, but there's a number line right here that has the negative side of a number line. And we're using these in class pretty often to graph values, to graph a set of values that will automatically put it in order from least to greatest. So if you have a situation where you need to put things in order, think about using number lines. And think about the fact that positives are always bigger than negatives, and that should drive some of the order that's going to be evident in some of those examples. Another thing that comes up often is, if I have a bunch of negative values, how should they look in order? And I always tell people that if you're looking at a number line, and I don't think you can see this, I'm going to try to show you that number line. That's kind of hard to see. I'll bring it over here anyway. But if you're looking at a number line, you see that 0 is in the middle of the screen right now. If you look to the right, you see 1, 2, 3. If you look to the opposite side, you see -1, -2, -3, and they almost look like mirror images. So if I'm looking at a mirror image and 1, 2, 3 goes to the right, then in the opposite direction we should have the same ordering. And I always tell people to look at your number line as if it's being folded in half, and 0 is the point of reflection, and you are simply showing the same order going in opposite directions. Again, number line is something I think that we've used previously, so this is something that we can use to kind of bolster our understanding. And if we're having a hard time with it, class time is a great time to discuss that and see if we can get better at it. Again, with ordering, use your number lines. If you're going to compare stuff with a greater than or less than sign, again, some of these hints are going to help. I'm going to move over to the next set of notes. You may have already seen it a little bit. Pause now if you need to. And if you don't, we're going to move on. Alrighty, no boards today, just chalkboard. And I think you can see everything on there. You might not be able to see my big head, so I'm going to move this up just a little bit. And there we go. Absolute value is basically, by definition, the distance from 0 on a number line. So whatever number I'm talking about, if I'm asked for the absolute value of it, basically whatever comes out of this brackets, is that the special absolute value bracket, whatever comes out of that needs to be basically a positive value, because we're only talking about strictly how far is it away from 0 on a number line. And so I'll use this example here. The absolute value of -3 equals 3. It's just 3 because it's 3 units from 0 on a number line. I'm going to show you that right now. If I look at my -3 and graph it, let's put a dot where -3 is. Okay? And if I were simply just to count how many spaces there would be from -3 to 0, it would be 3. 1 move, 2 moves, 3 moves. And that's that. That's that. It's a very easy transaction. If I said to you, what is the absolute value of +6? You could either imagine a number line in your head, or you can literally draw a number line and use it to figure out how many spaces it is from 6 to 0 on a number line. What's the answer? I'm going to assume you said, what about the absolute value of -1? For that one, you can use this graph if you wish. I think you said, and I hope you said, that. So that absolute value is very, very easy. And for our class, for our standard, we're talking strictly about just basic absolute value. However, in the coming years of math, you may see entire expressions inside these brackets. You may see entire multi-calculation expressions that may end up being positive or negative, but in any event, whatever comes out of these brackets is going to look positive. All right. And I just want to end out with a few real-life examples of using integers, because they come up everywhere in life. You know, we talk a lot in classes about sports applications of integers. I always like to use money because I think money is important, and kids need to have that financial literacy and need to know about using money math. And so I'd like to start off with some of these examples. A deposit of $26 indicates that your bank account is growing. The bank account is increasing. Okay, that amount of money you have is more. So by depositing, you're adding to your account. If you're adding, it sounds like a positive situation, don't you think? So this would be 26. Writing this as an integer would be positive 26 or 26. I'm not a big fan of writing the little plus sign, but if that helps you, then go ahead and do that. On the other hand, a withdrawal of $50 indicates that you're taking money out of your account. So you're subtracting money from your account. If you're subtracting it, then you have less money, and that would be an example of a negative integer. So this would be a withdrawal of $50, so I'll write this as negative 50. I'm going to let you do the last two by yourself and let you complete your own notes. But I'll give you a quick read on those. A gain of 18 students. If you were a teacher and you gained 18 students into your class, what kind of integer would that be? Would that be a positive integer or a negative integer? And I'll have you write that in the blank yourself. On the other hand, we have a loss of 4 dogs, which would be terrible to lose 4 dogs, but we won't imagine that you did it. We'll imagine someone else did it. A loss of 4 dogs. If you are losing something, what kind of integer do you think should be represented using that value? I'll let you fill it in yourself. If you have any questions, bring that to class. Bring these to class, and let's discuss this a little further. Thanks a lot for paying attention. We'll talk soon.